Hello. These particular Betamax tapes were particularly suited for use in the high-performance version of Beta called SuperBeta. And I've worked on a couple of SuperBeta machines, but they were USA models, NTSC television system. There were very few, in fact only one model of PAL SuperBeta machines sold in the UK. It's the SL-HF950, and of course they're exquisitely expensive. You just can't get hold of them. I'd love to.
Special delivery.
Oh, I say. I wonder what's in this great big box then. Could this really be the holy grail of every beta enthusiast video recorders? The one that's on every beta enthusiast's bucket list. The machine, especially in the PAL market, that you really, really want, right? Could this be an actual SL-HF950 SuperBeta? SL-HF950 with remote control enclosed. Hope you get it working without too much trouble. Oh, so do I. So this came from Steve. Let's start by looking at the remote. So this remote looks a little bit more sophisticated than other models, especially around the counter reset and display and rewind to zero and things that you don't get on other models as far as I'm aware. And you can switch the remote control commander off. I'm not sure if it's got batteries in it. We'd better check that they're in suitable condition. Oh look, they're current. My goodness. So this machine might have been working relatively recently. Oh, getting around the back, first thing I notice is a SCART socket, and I don't remember seeing a SCART socket on any other model of Beta video recorder. And there we have the legendary SL-HF950 SuperBeta Hi-Fi. What a wonderful machine. It feels like there's something wrong here with the sled loading system, so that will need attention. They always do. I'm fully expecting the VU meters to not work because it's the same as the SL-HF950. The VU meter is very similar, but I'm dab hand at rebuilding those. Oh, look at the controls in here. What a nice piece of kit. Oh, that feels good. But I'm not going to power it up until I've already taken the lid off and had a look inside. But it looks quite tidy. It's a little bit grubby, but nothing that won't clean up. It does have the headphone volume control, which is nice. That's missing off the last SL-HF9. Well, that was not a domestic video recorder, actually. That was a professional duplicator. Right, so let's have a quick look inside and see what's going on. Okay, looking inside, the first thing I notice is a leaky battery, and I believe that means it's a Mark 1 version of this machine. They are known for being the harder ones to fix and most troublesome. So I don't think I'm even going to power it up until I've at least got that battery out of there, and then we're going to have to investigate what the problems are with this sled loading system. Yeah, there's going to be plenty to work on here. Yeah, there's corrosion on that screw there, which means potentially this battery's oozed all over the joint. I think I'm going to have to take this top board off and inspect it. And to do that, I think I'm going to have to unplug all the connectors from it to be on the safe side. There's not that many. I'm hoping it's all connectorized. Okay, I've extracted the hideous battery, and it's left, well, it's ripped the pad off the PCB there, but that's just the negative terminal, so it's easy enough to replace that once I get a new battery of the correct type. More of concern is that these tracks, these sort of set that go to this IC, they're looking a bit the worse for wear, so I'll have to inspect them under a microscope and actually test them with a meter and make sure that they have not succumbed to this battery gunge. Okay, so we've lost a bit of the land there, so I'll have to clean that up, and where the PCB joins to the metalwork underneath, I'll have to clean that up. These tracks look okay. I'm not too worried about those. So I think we got away with it, really. Not too bad. Okay, I think I know which wire this is that's been sprung here. It's one of the wires associated with the dropout compensator, so I'm going to assume that somebody was using this at some point with a PCM decoder, which you would switch the dropout compensator off for. But in doing so, for best results, but in doing so, you would end up with a generally lousy picture because you get a lot of dropouts. So it's a really awful way to have switched off the dropout compensator. You would hope that someone would fit a switch somewhere, not just permanently disable it. But okay, I think we've figured out what's going on there, so I'm going to respring this connector and refit it back in the plug and put it back together. And the other thing I'm going to do, this was a 1.2 volt NiCad or nickel metal hydride battery initially, so I'm going to fit a modern one in there, and then we can get on with a little bit of testing. Well, I've just used my cheap and cheerful Chinese welding tool to weld some tabs to this 1/3 AAA nickel metal hydride battery, and just confirm there's 1.2 volts across there, so I can now install that in the board. I failed to record it, unfortunately. It was a little bit exciting, especially for the positive terminal. We had a little bit of a cloud of smoke, but you know, for a cheap and cheerful thing, these things really do work quite well. I tried to do some bigger strips of metal to do some work on the rusted base of a lawnmower, and found it was beyond this thing to weld that. But for this thinner material that you use for making up terminals for batteries, it's really excellent. A quick check then between negative terminal, which is common to this ground point here, and the positive terminal wanders all the way along here. To this point we should see about 1.2 volts. Yes, good. Right, so I can put all the wiring back together again, and I've now refitted the dropout compensator wire there onto pin 7 of that connector. So I'll put all this back together, and I think we'll go for power up. I know we're going to have sled loading problems, but let's just see what happens when we power it up. And you could argue I didn't need to undo all these connectors, and that was true, but if I hadn't, I may not have noticed that wire having been pulled from that rear connector, so I don't regret that at all. Is there a master on-off switch at the back? No, there isn't, so when I switch it on, it should hopefully, at least partly, come to life on the display. Okay, wish me luck. Well, something. The display's a bit dim. That's not that unusual. Okay, spins ahead, which at least means that the Hall effect sensor is working on the head. I will try and open it. Well, that sort of came out, but this is supposed to pop open. Yes, it's getting stuck on the way out. But the machine seems to be basically alive. This isn't right here either. This side is flush and this side isn't. So, right, we need to look at the sled loading. Now, this is an area I've never worked on, and I've no idea what to expect. But I'll start, I guess, by taking the bottom off and seeing what there is. These set of screws here should be fitted in these positions, I think, for transport. And they weren't, but then it's already broken, so yeah, to hold that shut, that's right, during transport, those things should be in there. Right, well, let's take a look at what we find underneath. Something's just fallen out, so there's a clue. Okay, we don't really gain much access to the sled loading there, but I'm glad I took the bottom off because something fell out. Let's power it up again. Okay, a little bit of user error there. The open close slides it forward, but eject will then pop it open, I think. Okay, so a bit of research and we find Mr. Betabyte has the answer to the question, what's wrong with this thing? And the problem is that a piece of plastic, i.e. this piece of plastic, has snapped off this rail here. So there's a rail here and it should go all the way to the back, and that piece of plastic has snapped off it. So we need to bring this all the way forward, and what's been happening intermittently is it's been jamming just about here. What's going on there is there's a plunger here which is sprung loaded and is pushing up, and it gets stuck there. So we need to give that, well, sort of roller a bit of a push down, and then we can bring this further forward, and that where it's stuck is where the plastic's broken off from. So we bring this forward, and now we'll need to release this, and we'll need to take the motor off here, some screws here, take this motor off, unplug it, and then we can bring the whole of the carriage far enough forward that we can gain access to the broken plastic and glue it back into place. Okay, there's the motor out of the way. You could unplug the wires, but I don't see the need. So now we should be able to draw this forward a little further. There are some clips that you can release. I can't remember exactly where they are, here and somewhere else, if you want to go even further forward, but I don't think I need to. Mr. Betabyte says that the slope should be to the back, not the front, so maybe this has been off before and refitted the wrong way round. So here's the part we want to refit. Oh, we do need to take it further forward because we need to clear this metalwork out of the way. A bit of plastic falling at the bottom from somewhere. Let's hope that's not too important. Okay, here is one of the clips we need to release in here. Get that pushed towards the inside as we go that way. And now we can go further. Yeah, we need to remove this component in order to be able to pull it further forward. So I'd missed that. And I think hopefully now we should be able to go further forward with this. Nope, still stuck. Right, so one more component to release. Is this one. With that swung out the way, I believe we can go all the way forward. It's feeling like the rails are really dry on this, really need some lubrication. Right, okay. Now it's as far forward as it's going to go, and we're well out of the way of the area we need to do the repairs here. So this has snapped off from here and that needs gluing firmly back into place. It almost holds itself in place, so we should be able to apply some epoxy resin to that. Right, we're looking at the side of the machine, so it's sat on its side here. This is the bottom and this is the opening drawer, and I was sort of re-greasing a few things and making sure it's going to work, and found this problem. So this is quite apart from the repairs I've done at the top there on that rail. That's fine, but this is crashing, and look, it just clearly isn't right. Someone's had the bottom off this part and not fitted it on straight, it would appear. So this part here just doesn't look right. I mean, surely that angle can't be right. and it's crashing, and if you push it, it sort of fits, but then it all scrapes along the bottom of here. So what could be wrong? I've not yet refitted the motor, by the way, so it's nothing to do with that. This to me doesn't look right, but there are sort of tabs here and they are fitted properly. Am I going to stick the whole machine upside down to work on this? Maybe I will. Trouble is I've got the motor slopping about here. I'm not sure it's all going to fit. Now I'm beginning to wish I'd taken the motor off, because the motor's hanging around here and may not allow me to close this board up and so put the machine upside down. So though it hadn't been my original plan to take the motor off, I will. I'm going to have to cut one cable tie off here as well, which you can't quite see, but there's a cable tie here, so I'm going to have to cut that off. Now take the motor away. Now I can close this board. Now I can have the whole thing upside down and try to work out what's wrong here. There's a screw. This has clearly been apart before. Remember I said that one side of it didn't close properly, didn't look right? That's because this screw here is not fitted properly. I see. I think that was correct. These are correct, but this was on the top instead of underneath this tab. That is why it was all jamming up. There we go. Much better. Now we can refit the screws and hopefully this will slide shut properly. But it's a bit worrying, why has this been taken apart? There's clearly something wrong here, or something's been repaired or not repaired. So there's, the machine's got some history. Okay. Now hopefully this will slide in okay. Now it's still not right here. This side is a lot better, but the other side is still dragging on the frame of the machine. It's better, but it's not right. Much better actually, but still not quite right. And why is this not quite clearing the space it's supposed to clear? It's so close. I think it's just a little bit bent. Okay, I think we've got it to clear. It's very, very fine gap along this edge. Okay, I have to reassemble this side. So we have that component, which I think is the lifter. Make sure that's working. Yeah, that's free to operate. Right, that's it. So I had to push that lever into this slot. Then refit the motor, and then there's a bracket to go on the top of that as well. Okay, a little bit wiggling and jiggling was involved there, but that looks good. Then that final top bracket, and then the 3 screws. And look at that, Sony give you a little slot there, so your screwdriver will fit properly. Now reconnect the motor. There's 2 wires, so one will be for the switch side and one is for the motor drive. So there's no need for a cable tie there, so I won't refit that. Okay, I've not refitted these screws on the PCB yet, in case we have to work on it some more. I'll power it up and see if we can operate the open mechanism. So, switch on. So if I press open close, it gets jammed. Something's not quite right. Okay, let's see if I can just physically look at what's stuck. Oh, I think my repaired track has fallen off. Yes, I thought I'd done such a good job of that. I was really pleased with myself. there without repair work, but it broke. Oh dear. I thought that was fitted so well it wasn't ever going to break, but it broke all right. So let me show you that if I can. So I've repaired, glued on the section along here, but this very heavily loaded spring popped it off again. And I don't know where it is at the moment. I need to find it. Need to find the part that's broken off. And I'm obviously quite concerned now that that plastic component is completely missing. Well, I can't get the sled out now because this won't go down. And the reason that won't go down is because it's sticking on a piece of broken plastic. So, I don't know if you can quite see it, but down here is a bit of missing broken plastic that's come off here. So I need to sort of ease it out of there somehow. There it is, all right. That's the bit of plastic we need. But I'm just going to have to get that out somehow. I'll have to do it off camera because I can't hold you at the same time as fiddling with that. So I'll get that out and then we'll probably have to do much of the same process again. Okay. There it is, and that was a bit of a fail for my epoxy resin because you can see it, you know, the epoxy resin stayed there, but it didn't stay stuck to the side of the machine. It just sort of fell off. Maybe I didn't clean it enough. Maybe that's the problem. You know, it's still well stuck to the plastic. I mean, it's done a really good job of that, but it didn't stick to the machine. Okay, I reckon I can work on this now without taking the carriage off. I reckon I've got enough room now. So what I wanted was for that to stay there. And yeah, maybe I should have had more glue on the side. I don't know. But yeah, I don't think I need to take this all out now to work on that. At least I hope not. But I mean, that's so good the way that glue has stayed on this. But so sad that it didn't stay on everything else. You know, that glue is really, really hard, but has not done the job. Because the force on that spring is huge. I think maybe I didn't apply enough. I think maybe along here, I don't know if you can quite see it. Where it broke here was on this fillet. So there just wasn't enough glue left. So I needed a lot more glue there, I think. Alright, lesson learned. So I need to make up the glue a lot more here because this will stay put, but I need to have a much larger quantity along the top and also onto this because of course that stays there. Yeah, I wasn't really making good use of the support at this end or that end, and that's why it let go. Alright. So I've got a bit of a gluing job ahead. I'll see how much of this I can rip off and do it again. I think a lot of what I need to do is glue this onto the metal. So I'm going to have the machine set on its side so the glue will roll that way, will flow that way. And I've done a good job of mixing the glue because I know that's key. Okay, so I've glued it again. This part here I think has now got so much glue on it that it won't fail. But I've finished gluing this some hours ago. I'm going to leave that overnight and then hopefully tomorrow we can close the sled all the way and hopefully it won't break, and then we can get on with testing the rest of the machine. Okay, here we are next day. I'm hoping now that I can slide this closed and nothing will break this time. Looks better. Okay. Can we switch it on and insert a tape? So eject. Right. So it sounds like it didn't detect it come to the end position, which is presumably a switch in there. When we had the motor out, perhaps we should have cleaned the switch. However, I can probably still put a tape in. No, it jammed. Oh dear. Oh, it's trying to lace when it's not fully inserted. Oh, that's odd. Right. Okay, so we still have sled issues, but we have a tape in there. I'm going to try rewind. I can see the tape counter just about. I've heard slightly better, but it's working. Fast forward. Okay, let's try play. Oh, a bit of a howl. Very faint noise. But that's not awful. Let's connect the TV to it and see what we get. Oh, we can use a SCART cable, can't we? That'd be nice. Okay, this will be the first time I've ever tried a SCART cable on a Beta video recorder. Switch it on. And we seem to have Capstan servo loss. I'll just try the tracking. Okay, let's try freeze frame. Very noisy. Not sure it's supposed to be better than that. Okay, so that's not great. Because it's not got servo lock, I don't think we'll see if there's Beta Hi-Fi sound, will we? Well, it says there is, but we won't really know. Well, I'm not hearing any sound on that. Alright. So we still have linear escape problems. I think the position sensor for the eject position needs working on, and Capstan servo, I understand there's some capacitors in the servo circuit which are responsible for that. Let's just try this one more time. If I hit open close, is that correct? That might be correct. So then when you press eject, does it come a bit further? Oh, then it... Oh, yeah. And then it gets stuck there. And then it gets jammed on the way in for some reason. Power it down. I don't know why it's getting stuck on the way in. That seems to be mechanical. So the fact that it's not seeing its open condition, that's electrical, I think. But the fact that it's not managing to go back in is mechanical, I think. Okay. Should I take the tape out for working on this? Maybe I should. So do that. So that must be a first position on that switch, and that's clearly working. But it's when I then hit eject and it comes out the rest of the way. Does the unlace. And is not detecting that it's completed that. Oh, that time it went in okay. So it seems to be struggling to go in with a tape in it for some reason. Oh dear. That's not good. We've left a loop of tape. So we may have a bit of a real drive problem. We did, of course, see that somewhat slow rewind. So that'll be issues with the rear drive. There's the motor wears on its shaft and needs a small sort of tiny washer inserted into there. So that's a lot of work actually. That's a proper pain. Right, IC301 here on the SS50 board is concerned with the Capstan servo. So I just looked at that and then noticed something. Sticky pads were a problem on some of these machines. They used sticky pads where they did bodge boards, especially on the earlier models such as this is. And so if we just look at this black sticky pad here and stick a meter across, you know, any 2 points of this black sticky pad, and we're starting to read resistances in the hundreds of kilo ohms area, depending how much I push the probes together. So this sticky pad has gone conductive. I will need to remove it, but it's got some circuitry on the top. The circuitry that's on the top there is going to be probably undocumented, so I'm going to have to check it with a microscope and make sure that I remove that carefully. So though this circuitry here may have nothing to do with the Capstan servo, I don't know, it's certainly very ugly and it's got to go. You can see it's starting to make the components go sort of green and crusty. No, this has got to go. So it appears to be there's a transistor here on the board and an extra transistor has been added with a capacitor to this point. Can I get that on screen? So capacitor comes over here. I will test the capacitor in a minute, but first I need to try to just get this horrible gunge out of here. So I'm going to have to pull these components somewhat out the way, I think. Right, so I think electrically that's still fine. This has got to go. Highly conductive, as you can see, right? Very conductive indeed. So if there are any more of those sticky pads, I need to similarly remove them. It's been quite time consuming. It's taken me about half an hour to get rid of that sticky pad. Just for completeness though, shall we now test it with that horrible sticky pad removed from the SS50 board? Because that is the board that's responsible both for driving this and for the Capstan. I'm sure this still won't work, but we'll give it a go. So open, close, comes out to there, that's correct. So it's supposed to be able to work the deck at this point, so you can open it to there and see the tape. But then when we go eject, it comes out here, still overdriving at that point. It gets stuck. Okay, so we still have problems with that. Let's try play. And we still have loss of Capstan servo. So it didn't help our problems, but that needed fixing anyway. Okay, things of note in the Capstan circuits. There's a couple of capacitors here, 10 microfarad capacitors, involved directly in the circuit here, which is Capstan error amp electronics. And can somebody just look at the circuit for me? Which is the positive side of these? You've got two capacitors in series, and the positive side I've just never seen this before, okay? You know, which is the more positive side? Well, that's 1.8 volts and that's 1.3, so that should be positive. And why would you have two in series? It's a very weird circuit. So that's these two capacitors here. I'm going to look at those, but the trouble is it's not the easiest thing to get to. This board, there's another board underneath it, so not quite sure how I'm going to gain access to that. But I want to look at, or possibly just change those capacitors. And while I was there, I noticed another one of these horrible sticky pads here. This IC, as far as I can tell, is associated with the freeze frame operation, so it's not relevant, but I'm not going to leave it, obviously. So, should we have a look at should we meter that one out? Oh yeah, but I'm getting meg ohms there across that pad, so that's coming out. Right, so that's another one to clean up. That's going to take me a little bit of time, and then I've got to work out how to gain access to this board. Right. Either I go in from the top or go in from underneath if I can take the panel out that's underneath it. Right, let's start by cleaning up this gunge anyway. Okay, I've cleaned up all that horrible gunge in that area. That's pretty good. Fortunately, it cleaned up a lot easier than the other one over here. So now I need to work out how to get to this bottom PCB. I've just noticed there's another bodge board here. Oh dear. There's a bodge board here, but someone has stuck that down with hot melt glue. That might be Sony, or it might be somebody's worked on it later. So hopefully there's no more of that horrible gunge under there. Right, okay, let's see if I can get to this area of the PCB from underneath. Oh dear, getting to this area of this SS-50 PCB is hard, because I don't just have to take a board off underneath to get to the print side of this, but there's actually two boards, so access probably isn't that way. I imagine what I've got to do is take these screws out and take the board off, though the modulator unit here is in the way. Probably just undo those screws to take that out of the way and then get to this board. I think that's the way we're going to have to go. Okay, I have some access to the area of the that crazy capacitor arrangement. So this is the circuit here, and it's just as per the schematic. It's not a typo in the schematic. You have two capacitors in series, both with their positive terminals on the outside and their negative terminals together, and no other circuitry in there. Which means, you know, if this side is more positive than this, then this capacitor is reverse biased, and vice versa. So these two capacitors, in my humble opinion, are going to suffer. I don't know if they're relying on the capacitors and not allowing themselves to become reverse biased by changing characteristics, so the impedance changes as it heads towards reverse bias. Why wouldn't you just use a non-polarized capacitor? And anyway, they're only 10 microfarads in series, so whatever that capacitance comes out to be, why couldn't you just use a ceramic capacitor for that or something? You know, it's only a fairly low capacitance. It just seems a crazier circuit. Now, I can't desolder these capacitors and measure them, because the desoldering will affect how they respond. You know, that will change their characteristics. So that's these two capacitors here, that one and that one. So I think the best thing I can do is cut them off and then test them and replace them anyway, just because, you know, they will have suffered. So they're 10 microfarad 16 volt. in a back-to-back arrangement. What an awful thing. Right, let's cut them off and test them. Okay, I've managed to extract one of them, which is C333. This is the one I suspect would be the one that could get reverse biased, at least according to the schematic. So let's find out. It's supposed to be 10 microfarad, so I deliberately did not desolder it because the heat of the soldering could reform it. What do we get? It seems to be absolutely fine, despite the abuse. And I'm going to take out the other one, which is C332. Okay, here's C332. If both of these capacitors survive fine, then clearly I know nothing about circuit design, and it's okay to reverse bias capacitors. Yeah, well, okay. So apparently that's okay, that sort of circuit. Still strikes me as very peculiar. I'm going to change those capacitors anyway, and then, well, we're going to have to do something a little bit more scientific, trying to work out where the fault may lie. Oh, also there's this capacitor here, which is also involved in the same circuit, which is C371, I think that one should be. 100 microfarad, 10 volt, looks to be the right one. I'll test it or replace it anyway. Should I do the same? I'll cut it off. So all those three capacitors are absolutely fine, but will be replaced anyway. While we're here, we see more bodge components with this hideous conductive sticky tape there, and then there's another one on the board below. So we'll remove all of that nasty sticky tape. So I've got plenty to get on with. Okay, I have removed all the sticky pads from under here, and one from the board underneath. So, and they're all, really manky. I will look for some more. There may be more in the boards underneath here. But for now, hopefully we're in a position we can put this back together and test what we have. I'm fully expecting the switch, by the way, in here that's concerned with detecting the position. It's kind of a mode switch that's concerned with detecting the position of the sled assembly to have lost its contact for the outermost, the eject position, and it's either going to be a dirty contact or something's actually broken inside, and I suspect the latter, because I had this small piece of black plastic fall out the bottom of the machine when we first got it, and that might be an actuator. So that might be the reason that it's not seeing when it's arrived at the outermost position. This goes in here. There's a little bit of rust on that. It's not very pretty. For some reason I can't get the modulator adjustment lever back in there. I won't worry about it for just for a minute because obviously I'm going to use a modulator anyway. I will refit that at another time when we've dealt with the serious problems. I'm not expecting things to have changed at all, but we'll give it a whirl, just see if by some miracle the Capstan Servo has decided to join the party, but I suspect not. Okay. Still no Capstan Servo, so we still have plenty more to do. I do have some ideas about how to solve what may be the problem with the real motor. That shouldn't be too hard to solve. I've got some ideas how to solve with the problem with it not stopping in the eject position. Don't quite know what I'm going to do about Capstan Servo yet. We may have to go deeper into the circuitry. Let's just... so that's the eject position, and it can carry on playing. Or not eject, that's the open close position, and I can carry on playing. Now go eject, it'll unlace, and then bring it out here, and then not stop. So that's a fault. And then it's not going back in either, it's jamming on the way in. Why is it jamming? It's just a simple mechanical problem, because when I take the power off, it can go back in. In freeze frame, the colour is terrible too. Look at that. It should be better than that. It's not a happy. There's something wrong there in the chroma circuits, I suspect. There's there's frame search, and yeah, it should look better than that. That might not be the easiest thing to fix, but in play the chroma looks fine, apart from the fact that we've got no Capstan servo. And ×9 picture search is not giving a picture at all. What about ×2? Sort of. I'm now on pin 8 of IC302, which deals with the control pulses. Pin 8 is its output, which goes on, in fact, as a test point, TP308. And we have track control pulses nicely amplified. And look, if I do, say, picture search, they'll go faster. Yeah. And freeze frame, they should stop. Yeah, that's it. So they are the pulses from the control head. I twiddle the tracking. I'm expecting absolutely nothing to change. No, absolutely nothing at all. So we need to find out why those pulses are not being properly handled by the Capstan servo circuit. Right, if the tracking control's faulty, it can cause these machines to lose, well, Sony machines in general, to lose Capstan servo. But looking at the tracking control, I'm looking at the response on TP301. As I adjust the tracking, this is the normal speed tracking, it is working. So that eliminates the tracking control itself. IC307 is the Capstan error amp. Pins 5 and 6 should appear to be much the same because it's an op amp, and pin 7 should be 6.5 volts. So let's see what we see on that when it's running. It's really awkward, I'm afraid, here. I can't really show it to you very well. It's buried under cables. So, pin 5, get about 1.18 volts, which is a bit low, I would say. Presumably pin 6 is about the same. Yes. So pin 7 won't be 6.5 volts. No, it isn't. It's 3. Okay. So we need to trace back why these 1.8 volt inputs to pins 5 and 6 are way off. The problem is here we don't know what's cause and effect. We don't know to what extent it's trying to correct itself and therefore is applying very different voltages to what's shown in the manual, or if it's wrong because the voltages are so different from the manual. Yeah, that's the trouble with this sort of circuit. You kind of need to know how it works and whether the voltage should be going up or down under various circumstances. So while trying to find some signals on IC301, I found something else. Another sticky pad. There. So that could be upsetting things. Let's get that sticky pad out of here. It might have gunged up some of the pins of IC301. It's very hard to get to. They've got a lot of cables over the top. This is untidy, Mr. Sony. This is just untidy. But let's clean that up and see where we are. Okay, I was burning the midnight oscilloscope last night a bit. I've also taken lots of readings here from the area around the Capstan servo. And some of the things I've realised is that a lot of these signals, or the whole of this section here, is concerned with an emergency shutdown. If it finds a very high voltage here going to the Capstan drive here, Cap VSX on the connector over here, if it finds that voltage go very high, then this transistor will activate and it will tell the machine to switch off. So that's not relevant because that's not happening. This signal here, this transistor and this transistor are concerned with when you do frame by frame or slow motion, and all that's working, and I've looked at the signals from that. So that's all fine. So what's wrong is here and here. We have, we're supposed to have 1.2 volts on this line here that goes out to the Capstan motor. but we're high at about 1.8 volts. And that's because this transistor here, 315, has got 2.3 volts instead of 1.8 volts at its input. So, you've got a diode drop there, so that's all sensible. But what is not sensible is here. According to the schematic, on the output of this IC, which is in there somewhere, you should have 6.5 volts, and then you've got a diode going to this transistor. But what I'm seeing is a bit more reasonable, really. I'm seeing 3 volts here and 2.3, 2.4 volts there. So that's a diode drop. So what's going on here? Why am I seeing this, according to the schematic, massive voltage drop across this diode D301? That's actually quite easy to get to. It's over here. So let's actually prove that. So this is the anode, and during the play operation, we're getting about 3 volts at that position, which is much too low. It according to the schematic, should be 6.5 volts. And yet, on the other side of that diode, I'm getting around 2.5 volts, 2.3, 2.5 volts, and it says I should have 1.8. That doesn't make sense. I should have 0.6 or 0.7 volts across that diode, and indeed I am, but according to the schematic, there should be some much, much larger voltage across that diode. So I'm now reaching out to you guys, anybody out there who's got one of these machines that works, please can you put it into the play mode and measure the voltage either side of that diode D301, which is quite handy. It's just on the other side of that heatsink, and the reason that's handy is because when this board is down, a lot of this lower panel SS50 is covered up, but fortunately that particular component is easy to access. So somebody has one of these machines, please would you be so kind and measure both sides of that diode during operation. And if you're willing, would you also, but this is a bit harder because you have to pull this board up, probably, measure the inputs to this IC301 on pins 5 and 6, there and there. We know pin 7, we know what I'm getting there is 3 volts, not the 6.5. I'm getting about 1.17 volts. Shall I just show that during play? So yeah, about 1.17 volts on pins 5 and 6, and there's 3 volts on pin 7. So can you try to give me some readings here? What is going on? And above all, why does the schematic show this impossible voltage drop across this diode? So we will stop at that point. Well, we've made some good progress with the SL-HF950 SuperBeta, and we're progressing with the fault finding. So I hope you've enjoyed what we've done here today. I'll do plenty more content on audio and video technology in the near future, and of course we will come back to this one. Bye for now. A few other little points. I want to say a big thank you to Alex, who's otherwise known as Mr. Betabyte. He's given me some good pointers on this machine. Something I'm not happy about is it has a bit of a wobble. And that's quite frustrating. And it's because one of the feet is missing. So I've borrowed one of the feet off the scrap SL-HF950 Beta Hi-Fi machine, and I'm hoping these are compatible. Oh, looks good. Oh, good. Okay, well that's a fault fixed. Good. Do you remember earlier on I had to refit a connector to, well, it was one of the pins to a red connector at the back of the machine, which had been sprung by a previous person for some reason to disable the dropout compensator. I was lucky nothing fell apart when I was doing that. If that connector had fallen apart, I'd have been really struggling to get a replacement connector and a crimping tool and what have you. Would you believe what LIDL are selling now? They're selling kits of, well, basically connectors for video recorders. There's not going to be huge demand for these. Now, you know, these are really only used in electronics, not sort of DIY or heavy electrical or the sort of thing that you'd expect LIDL customers to be interested in. This was $16.99. A YouTube subscriber emailed me to tell me about this, so I had to run off down to LIDL and buy this. Let's have a quick look at this. Get these pins out of the way. So let's take a look. We have PCB mount sockets and plugs to suit, and all the necessary pins for those, and not any old ribbon cable but rainbow cable. I always loved this when I was a teenager mucking about with electronics. And oh look, we've got edge connectors, we've got these 0.1 pitch connectors and pins for those, and the crimping tool. Oh, we've got some more connectors floating around loose in here for some reason, not quite sure why they're loose. And oh, that is decent ratcheting. Ah, that is really good. So all the correct sizes there, 1, 2 and 3, they're marked for crimping up these, and hopefully, yeah, the instructions will tell us which of those to use for the different types of connector. And more in here, and right down to 1 by 1s and 1 by 2s. Just everything you could hope for. So yeah, that is really impressive, and I know I've struggled with these connectors in the past. Okay, you need some bigger bits of cable for some of these connectors. You know, that's not the full width of that. But I'm really impressed with this. This is, even if you only use it once or twice, it's already earned its keep. So a lovely thing there from LIDL to help us video recorder repairers.